The analysis of data after it's been collected in the lab also requires the consideration and the use of significant figures. What we'll do here is take a look at an example that shows why significant figures need to be considered and utilized in the analysis of data. Here we have a rectangular solid, and what we're going to do is we're going to have student A, who will be in red, and student B will be in blue. Both students are going to measure the length of this rectangular surface as 11 millimeters. However, student A is going to measure the width of this as 3 millimeters, and student B is going to measure it as 4 millimeters. Now, in terms of measurements, we don't really have a problem with having those be off. The uncertainty in the measurement allows for the students to have a different answer for those two values. However, now what happens when we try to find out the area of this rectangular solid? So if we look at student A, the area would be equal to length times width. Length is 11 millimeters times a width of 3 millimeters, and we would get an area of 33 millimeters squared. If we look at student B, area again, length times width, 11 millimeters times 4 millimeters, and now we have 44 millimeters squared. So if we look at both of these numbers now, they don't seem quite as much the same anymore. Whereas their measurements were only off by 1 digit in the original measurements, it now seems like their calculations or their analysis is off by a much larger amount. All right, well, this is where the significant figures rules come into play. What we need to do is look at the numbers that you're multiplying together, and your answer can only have as many significant figures as the factor with the smallest number of significant figures. So for instance, if we go back and take a look at the numbers that were multiplied together by student A, the 11 has 2 significant figures, the 3 only has 1 significant figure, so therefore my answer should only have 1 significant figure. So I'm going to cancel that 3 out there, and I would report this, student A would then report this answer as 30 millimeters squared. Likewise, if we look at student B, 2 significant figures in the 11, 1 in the 4, so that 44 should be recorded as 40 millimeters squared. So now our implied uncertainty in each of their values is the 3 or the tens place, and the 4 also the tens place. And so now within the uncertainty in those values, the two students do have the same, within uncertainty, within the precision of the data, they would have the same area. If we look at this in terms of just a simple problem that we might see with more digits in it, here are 2 numbers that we're multiplying together. And these could be divided, we could be dividing these as well. You use the same strategy for division. Here you would look at the first factor as having 5 significant figures. And the second factor would have 2 significant figures. So we have to remember our significant figure rules that, here our 0 is between significant figures, so it counts. That's why we have 5 there. Here we have a 0 that's a placeholder value, or a 0 directly to the left of a decimal place. The numbers are less than 1, so it doesn't count. So we have 5 and we have 2, so therefore our answer should only have 2 significant figures. So we're going to have to get rid of all those other numbers there. So the answer that we would report would be 36 for the product of these 2 numbers. if we look at addition and subtraction, same general idea. We need to consider significant figures when we do this, but it looks a little bit different for this. Here's a 500 milliliter graduated cylinder, and because of the large size of the cylinder, the best we could do here for a volume is come up with 432 milliliters. And so that 2 there is our uncertain digit. That's one we're not sure about. Now, we're going to add this drop of water to that other sample of water. Now, a drop of water has a volume of roughly 0.1 or 0.2 milliliters. So we can say when we add this to it, is it going to change the value that we have there? And the answer is no. If I were to write this out, so 432 milliliters, and then we're going to add to that 0.2 milliliters, we can see that if we line up the decimal places on these two, that the 2 that comes from the drop is going to be added to a digit that we really have absolutely no idea what the value of that digit is. So if we do this on a calculator, our calculator is going to give us 432.2 milliliters. What we want to do is draw a line down so that all the numbers that are uncertain, or excuse me, all the digits that we know for sure are on the left, or that there are no uncertain digits on the left. Digits that we have no clue about. Digits that we have no clue about. So over on the right, then, we have this red star, which holds, we have no clue what that number is. So it doesn't really make much sense to add 2 to that number. So what we're going to do then for our answers, we're going to get rid of anything to the right of that. And so we report our answer then as 432 milliliters. Okay. Again, looking at this in terms of a more of a paper and pencil kind of problem. If I add these 3 numbers together, I'm going to keep in mind that the 2 places, the hundredths place and the thousandths place to the right of the 0.6, we have no idea about, nor do we have the 10,000ths place there or the 10,000ths place there. I'm going to go ahead and draw a line down so that all the red marks are to the right of that line. So we can see when we do that, all those totally unknown digits are to the right of that line. So now when I go to report my answer, what I would do then is I would need to get rid of anything that's to the right of that line that the calculator has given to me. What this then, again, what it means is that these digits right here are the result of adding digits to digits that we have absolutely no clue about. We can use those, however, to round. So in this situation, we would use the 8 to round the 0 up to a 1. So the answer we would record here would be 199.1 for whatever the units that we're combining there. Now, what this also brings into question then is, what do we do with rounding? So it's pretty simple. If the number that preceding the digit is, or the number we're using to round is a 5, or excuse me, is less than a 5, then we would leave the digit the same. So you can see here where we have 7.63 rounding to 2 significant figures, we would have 7.6. If the number were equal to or greater than 5, then we would increase by an increment of 1. So rounding 9.26 to 2 significant figures will give us 9.3 for an answer. Make sure you don't go farther to the right in terms of rounding. Just that first digit is all you would use for the rounding. So we just need to basically practice a bunch of these things, get comfortable with them, and it should make more sense as you become more comfortable with doing the calculation.